You ever wonder what's really going on inside the machine when an AI creates an image? Well, today we're going to pull back the curtain on the incredible science that's making these AI artists faster and, a whole lot smarter. Let's dive in.
I mean, we've all been there, right? You type in something wild like a corgi dog on a grassy hill wearing a tiny crown, and bam, in just a few seconds, a brand new, sometimes absolutely stunning image just pops into existence. It really does feel like magic.
But, that magic can also be, painfully slow. And sometimes the results are just weird. The AI makes these bizarre, nonsensical mistakes that kind of reveal it doesn't really get what it's making. It's like there are some serious problems hiding under the hood.
So that's the big question, right? How are researchers fixing this? How are they making this technology faster and smarter? Today we're going to break down the two biggest hurdles for these AI artists, speed and, intelligence. And we'll look at the seriously clever solutions that people are coming up with.
Okay, let's tackle challenge number one, the slow crawl. Why in the world does it take so long to generate just one single picture?
Well, the answer is all about how these things work. They're called diffusion models, and they don't just, spit out a finished image. Nope. It's more like they start with a canvas of complete static, like an old TV screen, and then they slowly, step by step, chip away at the noise to reveal a picture.
And when I say slowly, I mean really slowly. We're talking about a process that can take 1,000 individual steps. Each step is just one tiny, tiny adjustment, slowly pulling a clear image out of all that noise. It works for sure, but it creates this massive bottleneck, because step 2 can't start until step 1 is totally done, and so on.
So to put a real number on this, one study found that making just one small image this way took around 24 seconds. Now you might think, hey, 24 seconds, that's not so bad. But in the world of computers, that is an absolute eternity. Especially if you're trying to generate, say, hundreds of images for a project. It just adds up.
So the big question becomes, how do you break that one step at a time bottleneck? Well, researchers have come up with a couple of really brilliant shortcuts to speed things up.
Okay, so the first solution is actually pretty simple to wrap your head around. Imagine a master artist who takes like 1,000 tiny brush strokes to paint something. What if that master could teach an apprentice to get the exact same result, but with just 2 big, bold strokes? That's the basic idea behind a technique called progressive distillation.
And the way they do it is really cool. You start with your fully trained 1,000-step teacher model. Then you train a new student model to get the same quality, but in half the steps. Once that student gets good enough, guess what? It becomes the new teacher for another student who learns to do it in even fewer steps. You just keep repeating this, distilling the knowledge down until you can create an amazing image in just a handful of steps. Super clever.
Okay, but what if we could get even more radical? What if you could just skip the steps entirely? Like all of them? What if you could just solve for the final image all at once? Well, that's the wild idea behind the second solution, which uses something called deep equilibrium models.
So here's the key difference. The old way is sequential, right? Step 1, then step 2, then step 3. It's like a line at the bank. This new way is parallel. It treats the entire 1,000-step journey as one giant math equation and just solves it all at once. It's looking for the final equilibrium point, the finished picture, without having to walk the whole path. This shift from one by one to all at once is a total game changer for speed.
Okay, so making the AI faster is awesome, but it's really only half the battle, right? We also have to make it smarter. Why does an AI that's been trained on millions, maybe even billions of photos, still churn out a dog with one eye, or a tennis ball that just kind of melts into the court?
Well, the problem is that AI can be a little lazy. It takes these mental shortcuts. Instead of learning what a squirrel is, a furry creature with a bushy tail, it just learns to associate the word squirrel with whatever is usually in the background, like leaves and branches. Researchers call these spurious cues. It's a cheap trick.
And this is a perfect example of what I'm talking about. Look at this. When researchers asked the AI to make this image more squirrely, what did it do? It highlighted the leaves in the background, not the actual squirrel. And with the tennis ball, it focused on the white lines of the court. See? The AI learned the wrong lesson. It's just a cheap trick, not real understanding of what these objects are.
And this kind of fuzzy thinking can lead to some seriously weird results. Check this out. One research paper pointed out that even after 200,000 training steps, the model was still spitting out this thing. It's supposed to be a dog, but it's got one eye and one ear. It's completely failing to grasp the basic rules, like dogs usually have two eyes. So, that's the challenge. How do you teach an AI to, actually pay attention to the right things and understand how a face or a scene is supposed to fit together? Well, once again, researchers have a few tricks up their sleeves.
Okay, so there are a few really cool ways to do this. First, you can basically train the AI to ignore distractions by feeding it tricky examples designed to fool it. Second, you can turn the whole training process into a puzzle, like you hide part of the image and force the AI to learn the context to fill in the blank. But maybe the most powerful method of all, you hire an art critic. An AI art critic, that is.
This art critic idea is seriously a game changer. Here's how it works. You train a totally separate AI called a discriminator, and its only job, its whole purpose in life, is to become an expert at spotting fakes. It gets really, really good at telling the difference between a real photo and an AI-generated one. Then you have this critic look over the main generator's shoulder at every single step of the process, giving it feedback and nudging it in the right direction to make something that looks way more real.
And the results? Whoa, they are absolutely stunning. Look at the dog on the left. Without the critic, the model just forgets the eyes. It's a mess. But with that critic guiding it, boom, the dog gets its eyes back. Or look down here. The standard AI gets stuck in this rut, just making the same boring close-up of a burger over and over. The critic steps in and encourages some variety, and suddenly you're getting whole meals with fries seen from different angles. It's a huge difference.
So think about it. When you put all of these different pieces together, the speed boosts and these new smarts, what you get is a whole new generation of AI artists. They're not just way, way faster. They're also fundamentally smarter and a heck of a lot more creative. All right, we've covered a ton of ground, so let's do a quick recap. To make AI faster, we can teach it shortcuts with that teacher-student method, or we can solve all the steps at once using parallel processing. And to make it smarter, we give it an art critic to provide real-time feedback, forcing it to learn what things really look like and to stop getting distracted by the background. Every single one of these breakthroughs is a massive leap forward, just pushing the envelope of what's even possible. And it leaves us with this one really fascinating question to think about. As these AI tools become nearly instant and so much more intelligent, what happens next? What kind of creative boundaries are they going to break? What new forms of art and design are we about to see? It's going to be interesting to find out. Thanks for tuning in.